All right, here we go. End of the road, page 6 of the Unit 2 test review. All right, this is all about parallel lines and kind of an introduction into proofs. So let's finish strong here. We are given L is parallel to M. Okay, 8 is supplementary to 10. So supplementary, of course, meaning they add up to 180 degrees. So we are going to just go ahead, start off. I'm going to write down all that given information. So L is parallel to M. Right? And angle 8, see if I can fit all this in here, is supplementary. I'm not, is supplementary to angle 10. All right, that is all given information, right? This is why we number our steps, because my reasons column is, it's off now. So we have our statements, we have our reasons. Now, L and M are parallel. That is useful. 8 is supplementary to 10, and that is also useful. I'm gonna use this. All right, what does that mean? All right, I think I mentioned that earlier. 8 being supplementary to 10 means angle 8 plus angle 10 equals 180 degrees, right? We know that is the definition of supplementary. Okay, so now there's a few ways I could do this, but here's kind of my strategy. I am going to pick angle 10 and angle 4, right? Angle 10 and angle 4. If I just ignore this middle line here, right? Angle 10 and angle 4 are same side interior angles. If I can show that angle 10 plus angle 4 equals 180 degrees, then we're done, right? That is the, we can conclude that the lines are parallel. So that's what I'm going to go ahead and do. That's kind of my strategy here. So it's never a bad idea to think through your strategy before you start writing stuff down. All right. So step number 3. All right. I'm going to say angle 8, angle. What am I doing? Going the wrong side here. Let's try that again. Angle 8 is congruent to, how about angle 4? All right, I'm going from angle 8 to angle 4. How can I make that jump? Well, these are corresponding angles. All right, so corresponding angles. And I know they are congruent because I know that the top two lines are parallel, right? That was part of the given information, that L and M are parallel. And when we have parallel lines, we can say the corresponding angles are, in fact, congruent. All right, now, step number 4, I'm going to use step 2 and step 3 together to make step number 4 here. I can say now, instead of saying angle 8 plus angle 10, I can say angle 8. No, I can't. I can say angle 4 plus angle 10 equals 180. All right, that is step number 4. Why can I say that? That is the substitution property. Substitution property. I am substituting out angle 8 with angle 4 there. All right. Now, just like what I said before, since angle 4 and angle 10 are same side interior angles, I can conclude now that line L is parallel to line N. All right, and I'm going to say because the same side interior angles are supplementary. Right? And that one's done. Again, a few different ways you could have done that problem. That was just kind of the first way that I saw it. I think that might be the most efficient one. But this, is a good reason or a good demonstration of why we number our steps. Look at statement 3 versus reason 3. All right, they're not lined up horizontally, so they're getting kind of off. So help the reader, aka me, know which statement goes with which reason. That's just going to make my life a lot easier when I'm grading these things. 48 and 49. These are algebraic proofs. All right, so this is kind of a throwback to before we even started these, parallel line things. So the given information here is just the algebra problem. All right, now on these, we're just solving. We're solving the algebra problem, but we are just writing down every step as we go, right? In our algebra class, we don't really do that. But in geometry, we like to back up all of our, all of our maneuvers with a reason. So the first thing I'm going to do here is I'm going to multiply the 5 over. And I'm going to say, all right, 2 times x minus 12 equals 5x. I multiplied both sides by x. That is the multiplication property of equality. I'm just going to abbreviate this mult. All right. Now, step number 3. I'm going to go ahead and distribute that 2 in. So we say 2x minus 24 equals 5x. All right. On that one, I'm going to say that was the distributive property. Again, abbreviating here. Step number 4. Let's go ahead and subtract the 2x over. So if I subtract the 2x from both sides, I'm left with negative 24 equals 3x. Therefore, I can say, what am I doing there? I'm using the subtraction property. All right. And last but certainly not least, step number 5. I'm going to divide both sides by that 3. So I'm going to say negative 8 is equal to x, which is exactly what we're trying to prove. All right, that is the division property. All right, now, if I really want to be picky, all right, I know a lot of 8th grade teachers do this, or a lot of middle school teachers do this. They're going to say, no, you need to rewrite the problem with the x on the left side, and you need to say x equals negative 8. All right, so if we were to do that, this is an example of the symmetric property. All right, we don't use that one too much in this chapter, at least. We'll end up using that one in a little bit here. But that is the symmetric property. If we wanted to look exactly like the proof statement, that's what we would want to do. If you don't do step 6, I wouldn't take off for that. But it is technically, that is the correct thing to do. All right, but that one's done. All right, I got one more here. This is a long problem. 3 times, I'm going to try to fit all this in. 3n plus 1 minus n equals 29 plus n. All right, this is all given. All right, step 2. Man, there's a lot we could do here. I'm going to distribute first. So we got 15 n plus 3 minus n equals 29 plus n. All right, that is, what did I do there? I used the distributive property. All right. Oh, from here, I'm going to make this a little bit smaller. I'm going to say 14n. 14n plus 3 equals 29n. How about 29 plus n? What did I do there? What property did I use? I'm combining like terms. Combining like terms. All right. Next, step 4. Let's see. I have more n's on the left side, so I'm going to subtract an n from both sides. I'm going to have 13n plus 3 equals 29. All right. What did I do there? I used the subtraction property of equality. Right, I'm subtracting equal amounts from both sides, right? That's the most important rule of algebra. Whatever you do to one side, you have to do to the other. And in this case, we are subtracting. Well, guess what? I'm going to do that same exact thing again. I'm going to subtract a 3 from both sides, and I'm going to be left with a 26. All right, that is subtraction again. And last, but certainly not least, divide. I'm going to divide both sides by a 13. 26 divided by 13 gives us a 2. That was the division property. And there we have it, right? That is our 6-page review for, this is our Unit 2 test. I know that was a lot. The test is nowhere near that long, but that was a pretty comprehensive list of everything on the test. So really, just to kind of recap, make sure you know what your conditionals are, your ifs, your thens, your converse, inverse, contrapositives, linear pairs, vertical angles, especially I think I have it on the next page here. This, right? This is going to be, the bulk of the chapter was all about this parallel line stuff, alternate interior, alternate exterior, corresponding, same side stuff, right? So really make sure you know which one is which. Do you set them equal to each other? Are they congruent? Are they supplementary? Do you add them up and equal 180, right? These are things that we have to be aware of and know how to do. There's going to be a few algebra problems. Let's see, where's one of these where we had to translate? All right, so there's for sure one of these types of questions where you have to build the equation. All right, so just make sure you're looking over that review, and hopefully you're watching these videos. Got to get that subscriber count up, right? All right, so there we go. That's our Unit 2 review, and good luck.